Guardrail Tensions. Fable shipped Monday. By Tuesday, the security community was filing complaints. Cybersecurity researchers report that Anthropic's newest model blocks innocuous requests containing keywords like exploit, payload, or reverse shell, terms that are table stakes in any penetration test or vulnerability assessment. The frustration is compounded by timing. Fable was positioned as the most capable model in Anthropic's lineup, and security professionals who upgraded specifically for its reasoning capability found themselves locked out of their primary use case. The guardrails appear to be keyword-triggered rather than intent-aware. Researchers can sometimes bypass them by rephrasing, but the default behavior forces a fallback to Opus 4.8 for anything that smells like offensive security. Santiago Palmiotti of IBM, X-Force Red, and Matsui of Tolmo have both publicly criticized the restrictions as counterproductive, arguing that the people most likely to trigger keyword blocks are exactly the people doing legitimate security work. The contrast with Nullsec S1 is instructive. Rather than restricting a general-purpose model, the Nullsec team built a purpose-specific security auditor, a QLoRa adapter on Q, WEN2. .5 Coder 7B trained explicitly to find vulnerabilities in AI-generated code. On a 111-case benchmark, it achieves an F1 of 0.9245 with a 0% false safe rate, meaning it never marks vulnerable code as clean. The hallucination rate sits at 6.7%, managed by a deterministic safety layer that applies 8 check dimensions and 6 validation rules before any output reaches the user. The taxonomy of 16 security categories, including MCP tool abuse and prompt injecting, reflects the threat model that actually matters for AI-assisted development. The lesson: blanket keyword filtering is a blunt instrument. Domain-specific tools that understand what they're looking at tend to produce better outcomes for everyone involved. The accountability gap. Damian Charlaton's hallucinations database now tracks over 160 legal cases across the United States, Canada, France, India, and Israel, where courts found AI-generated citations in legal filings. The sanctions are no longer gentle. In Withers v. City of Aberdeen, a Mississippi federal court revoked pro-hack vice admission, disqualified resident attorneys imposed monetary fines, and referred counsel to state bars. All over 6 hallucinated case law citations. A Ninth Circuit case produced a 6-month suspension and bar referral for 7 fabricated citations. In France, the Tribunal Administratif de Grenoble identified a 300-page filing as manifestly generated with artificial intelligence, citing non-existent judicial decisions, and imposed a €200 fine. The volume of cases is accelerating. The database itself has spawned Pelican, a detection tool purpose-built to catch hallucinated legal citations before they reach a courtroom. The accountability gap runs deeper than courtrooms. This year's AI productivity headlines are all volume claims dressed in outcome clothing. Google: 75% of new code is AI-generated. Anthropic: 80% of merge production code is written by Claude. Engineers ship 8x more code per quarter. Cursor: 100 M+ lines of enterprise code written per day. As one observer notes, percent of code written by AI is just lines of code with a better publicist. These numbers cannot fail. Adoption is the one metric guaranteed to rise regardless of whether anything got better. Meanwhile, Meter effectively walked back its earlier finding that AI makes experienced developers 19% slower, abandoning the study design entirely because developers now refuse to work without AI and cannot reliably self-report time on agentic work. An NBR survey of roughly 6,000 executives found 9 in 10 firms reporting no measurable productivity impact. The cross-study consensus hovers around 10% organizational gains. Useful, but not "you don't need developers anymore" territory. The irony is sharpest at Anthropic itself. Its marketing arm claims 8x more code shipped per quarter. Its research arm published an RCT finding that AI-assisted developers scored 17% lower on comprehension of the code they had just shipped, with no statistically significant productivity gain. Both things are true at once, which is rather the point. Yet these volume claims move budgets. Jack Dorsey cut over 40% of Block's workforce, 4,000+ people, with AI as the explicit thesis, in the same announcement conceding the business was strong and gross profit growing. Atlassian followed suit, conceding it would be disingenuous to pretend AI doesn't change the mix of skills we need. When a company says, AI made everyone more productive, so we need fewer people, the evidence for that claim matters, and it does not yet exist at the scale implied. The question to carry into every vendor pitch and exec review: is that an outcome or a volume? Architectural ceilings. 2 papers this week isolate specific, measurable limitations in transformer architectures that are not going away with scale. The first, published in Peneus Nexus, uses the classic color Stroop task to demonstrate that transformers lack executive control of attention, the capacity to detect conflict, maintain task goals, and override prepotent responses. The researchers administered Stroop tasks to GPT-4o and Claude 3.5 Sonnet across word lists of varying length. Both models showed human-like interference at shortlists, but performance collapsed catastrophically as lists grew. GPT-4o's incongruent accuracy fell from 91% at 5 words to 15% at 40 words. Claude held up longer, 76% at 20 words, but still crashed to 24% at 40. Humans maintain 7% accuracy even in hour-long, 500-word sessions. The key finding: this persists across GPT-5, Claude Opus 4.1, and Gemini 2.5 Pro, confirming the limitation is architectural, not a matter of scale. The softmax mechanism routes information competitively, but there is no mechanism that evaluates whether current processing remains aligned with the task goal. The researchers also tested for congruency sequence effects, whether conflict on a previous trial improves performance on the next, and found no consistent evidence of trial-to-trial adaptation in either model. Humans show this effect reliably via the ACCD-LPFC pathway. Transformers lack the circuit entirely. The second paper from US and Google Research uses shortest path planning on grid maps to measure two distinct axes of generalization. Models achieve strong spatial transfer, over 90% success on unseen maps, demonstrating genuine algorithmic competence. But they consistently fail at length scaling. The authors trace this to recursive instability, even when a model can solve each subpath individually. Composing them into a correct end-to-end solution fails. This is not hardness accumulation. It is compositional instability dominating the failure mode. Reinforcement learning via GRPO stabilizes training but never exceeds the best supervised fine-tuning ceiling. It is a robust fallback, not a capability expander. The paper also offers actionable training data insights. The number of distinct questions matters more than the number of solutions per question, and coverage. The fraction of unique primitives seen during training sets a hard ceiling on performance. These findings validate on MathQA with QWEN2.57b, suggesting a general property of LLM learning rather than a synthetic domain artifact. The one intervention that actually rescues length scaling is prosaic. Add a few training examples at or slightly above the target length. Length generalization must be explicitly scaffolded in the training distribution, not expected to emerge. Agent literacy. The Claude Code versus Codex debate is producing more heat than light, but one framing cuts through. Claude Code feels like a cockpit. You are close to the model, steering it, stopping it, correcting its plan, wrestling with ambiguity together. Codex feels like an operations desk. You dispatch jobs in parallel, each sandboxed, each returning inspectable artifacts with proof of completion. As one observer puts it, the skill of 2026 is agent literacy, not prompting, not which model wins a benchmark this month. The skill is writing assignments that come back as inspectable work, and knowing when to steer versus when to dispatch. Claude's failure mode: it seduces you with great conversation and makes you feel closer to the work than you are. Codex's failure mode: a completed run that makes the work feel more done than it really is. Both still require judgment. Both still require proof. Cole Medin's harness engineering framework provides the structural vocabulary. An AI harness has two layers: a within-session layer, rules, skills, MCP servers, LSP integration, hooks, subagents, and a multi-session orchestration layer, persistent loops, durable workflows. The key insight: every mistake becomes a rule. The Clota.md file is not a config dump. It is a standing body of institutional knowledge that evolves with the project. This is infrastructure thinking applied to agent management, and it separates practitioners who use AI from those who operate AI systems. The multi-provider workflow is maturing. Medin's Archon harness demonstrates a practical approach. An 8-node YAML pipeline where Opus handles planning the only step that truly requires the most expensive model. Gemini 3.5 Flash handles UI design creative, but unreliable at following complex instructions, and Sonnet handles cheaper validation steps. Each node communicates via markdown artifact files in a shared workspace directory. The demo: a benchmarking dashboard built from spec to near deployment. Ran without manual intervention, though Gemini skipped a critical artifact writing instruction while producing a clean, non-generic UI in a single pass. The integration node Opus ran for 31 minutes handling clerk authentication setup, but completed with full auth working on first attempt. The practical implication: use the cheapest model that meets each step's reasoning requirement and expect the creative models to occasionally drop instructions. The distinction between CLI and skill is sharpening. A CLI is a capability, what you can do. A skill is an instruction manual, how to do it. Google's Agent CLI is highlighted as an example of this convergence. Meanwhile, Codex now runs from a phone with computer use plugin for UI testing. Claude Code integrates with Obsidian as a command center with custom metrics dashboards. And the web design CLI ecosystem around Claude Code continues to expand with Impeccable, Playwright, Supabase, GitHub, and Vercel rounding out the toolkit. Speed as product. A deep technical breakdown of Linear reveals that its perceived speed is not the result of optimization passes. It is an architectural commitment made from day one. Linear treats the browser as the database. All project data lives in IndexedDB on the user's machine, with an in-memory pool of MobX observables as the primary data source for the UI. Mutations apply locally first, then sync to the server over WebSocket. There are no loading spinners because the data is already local. Reactivity is granular to the individual property level. Changing one field on one issue re-renders one cell, not the list. The team has rewritten their bundler setup 4 times. Parcel to rollup to Vite to roll down. And precaches roughly 1,200 assets via service worker. The total JavaScript payload is 21 MB, but aggressively code split into hundreds of chunks fetched in parallel via module preload. Animations use only GPU composited properties transform, opacity at 80 to 120 ms durations. The overarching point. This cannot be replicated by applying individual optimizations to a conventionally architected application. Speed at this level is a product decision. The React compiler is being ported to Rust, and the numbers justify the effort. 3x faster as a Babel plugin, approximately 10x faster as a direct transformation. The architecture was guided by humans but majority coded by AI, porting the SSA/C, FG/H, R pipeline pass by pass with 1,725 fixtures passing. OXC and SWC integrations are in progress. This is an experimental whip pull request, but it demonstrates the pattern. Rewrites that deliver order of magnitude speedups and are economically viable because AI dramatically reduces the labor cost of porting. Extend UI ships an open-source React component kit for rendering PDFs, DOCX, XLSX, and CSV files with bounding box citation overlays. The kind of document viewer that every RAG application eventually needs but nobody wants to build from scratch. It solves a specific pain point, showing users exactly where in a source document an AI-generated claim originated with spatial precision rather than page-level attribution. End-to-end builds. Tessera is a from-scratch LLM stack built around a single goal: distill a large teacher into a small student, then serve that student efficiently. The scope is deliberately comprehensive. Custom Triton and CUDA kernels flash attention forward, fused RMS norm, fused SWILU, int8 dequantizing matmul, FSD, P/03 training with atomic sharded checkpoints, a serving engine with block page KV cache and speculative decoding, post-training quantization in 8, AWQ, FP8, and a Rust/Axum gateway calling into Python via Pyo3. A JAX reimplementation of the forward pass serves as an independent parity check. Everything runs and is tested on a laptop. The GPU kernels fall back to torch references on non-NVIDIA hardware. The project is small enough to test thoroughly. Each Triton kernel matches its torch reference within floating point tolerance. Sharded atom matches single process atom step for step. Tencent's UNRL provides a unified reinforcement learning framework for multimodal models, supporting Stable Diffusion 3, FLUX, WAN, Hunyuan Video, QuenVL, and Quen3. It introduces DRPO and FlowDPPO algorithms with Ray Device Pool Orchestration, FSDP, and LoRa synchronization, a single training harness that works across image generation, video generation, and language models. SafeAdapt from Imperial College London introduces the Rashomon set, a certified region in policy parameter space where every parameterization is guaranteed to satisfy safety constraints. Using interval-bound propagation from the neural network verification literature, it computes tight bounds on how network outputs change as parameters vary, then constrains downstream RL adaptation via projected gradient descent to stay within the certified region. It is the only method in their experiments that maintains a critical state safety rate of 1.0 after adaptation. EWC and unconstrained PPO both exhibit catastrophic forgetting of safety. The method operates in 3 phases: constructing a safety dataset from an unsafety labeling function, computing the certified region using the LIDI verification framework, and constraining PPO updates via projected gradient descent to stay within the certified region. Currently limited to finite discrete state action spaces, and the IBP-derived bounds become conservative for larger networks. But the conceptual bridge between formal verification and RL adaptation is the contribution that matters. AE Ford Maka deploys 4 specialized agents for CNC manufacturing of T6L4V rotor blades, a central agent for intent routing, an analysis agent that performs all quantitative computation through deterministic tool calls, never unconstrained LLM generation for numbers, a knowledge graph agent retrieving from 2,701 machining triples extracted from 4 research papers, and a critic agent enforcing physical plausibility and provenance completeness. On a 75-question benchmark spanning 3 tool use depth levels, it improves tool execution success by up to 87.5 percentage points versus single model baselines. The critic agent alone recovers 61% of degraded trials. In a digital twin compensation demonstration,
The architecture reduced predicted surface deviation from approximately 0.01 inches to 0.001 inches across most of the blade surface. The complete reasoning loop executes in 4.3 seconds. Negligible versus machining cycle times. The architecture treats the LLM as a reasoning coordinator, not a source of quantitative truth, and that strict separation is what makes it viable where physically implausible recommendations cannot reach a human operator.